Good afternoon, everyone. And welcome. My name is Amornvit. Vatcharaphrueksadee. You can call me Bill. I'm the moderator of this panel discussions. We just have like 30 minutes to tackle one of the biggest questions facing Thailand digital economy right now. So how can our data center can keep pace with the explosive demands of AI and their urgent need for sustainability? So it's massive balancing act. We need gigawatts of power AI. We also have strict ESG goal. We need to incredible performance, but we also need ironclad securities. So here us find the answer. We have three extreme guests. extreme guests. So first we have the Darren Webb. So he's a co-founder and CEO of the Evolution Data Centers. He's one of the frontline building the physical infrastructure here in Thailand. So secondly, we have the Hasan Siraj. So head of software products and ecosystem from Broadcom, who provide the core technology, the high-speed networking and silicons that make AI possible. So lastly, we have Kunjo Piyoros Tungthamthiti, Vice President of AI Technology at Ngern. He represents the enterprise customer, a leader in financial service, who need performance AI and security today. So let's dive in for the first topic. So the first question is, let's start with the heart of AI booms. So the demand of AI of the high density computing is unprecedented. So Darren, from the operator perspective on the ground in Thailand right now, so what is the single biggest physical bottleneck to deploying a ready data center at scale right now? Is it securing sufficient power, access to water for cooling, or something else entirely?
Thank you for the question. So it's definitely power. Land was a challenge of yesterday. If you're looking to deploy in Bangkok, that's a different challenge. But of course, if you want to do it at scale, you're going to move out to the EEC, to Rayon, etc., where there is lots of land. So if you drive up there, you'll see plenty of still land available. So land is not really the challenge in Thailand. The challenge is, can you secure the power? And I really enjoyed the last presentation by BOI. I do think there are probably some challenges coming to this market in the next couple of weeks. I think we'll start to see some announcements come out of PEA and then subsequently MEA. And that's really going to be a huge challenge, because for the last year, all we've seen is announcements, new operators coming in, and that's fantastic. But underlying, I think it said 2 gigawatts up there. I think there's been applications of more like 5 gigawatts. It's important to bear in mind today that the market's probably still 100 megawatts of deployed IT capacity. So talking about 2 gigawatts, 3 gigawatts, 5 gigawatts is huge growth. And that's where sustainability becomes a challenge as well, but we'll come back to that later, I'm sure, in the questions. So power is very much a challenge. Before we were building data centers 10, 20 megawatts. In Thailand today, the biggest is built and deployed. STT probably at 24 megawatts, phase one, something like that, I guess. We're certainly talking about 10 times that in a single campus. So clearly power... And it's not, I don't think it's necessarily the power generation. How does it get distributed from substation to site? How quickly can we build that infrastructure? How quickly can EGAT support MEA, PEA deploy it? How quickly can the substations be built on site, because you have to break down if you're taking it at 115, etc. There's enormous logistical and physical challenges that Thailand has not faced today. And I would suggest it's been perhaps a little bit naive in terms of how easy they are to be solved. I think in the next 1 to 2 years, we'll see some enormous challenges coming through.
So thank you, Darren, for very insightful answer. So it's very challenging, in the near futures. So next we move into Hasan. So what are the critical networkings and silicon innovations required inside the data centers to manage this incredible, powerful heat generating AI cluster and prevent data bottlenecks?
So, one thing that we need to understand is the AI data centers are very different from the traditional data centers. The traditional data centers were built to solve a very different problem, which you can call a virtualization problem. This is, you had a lot of compute, you were virtualizing that compute, and you were running different applications in those data centers. Now, in the case of AI, when you're training these models or doing inference, these models don't fit in a few cores of a CPU, 10,000 cores of a GPU. In many cases, they will require tens, hundreds, thousands, hundreds of thousands. And in a few years, we're already having discussions, a supercomputer which is consisting of 500,000 or 1 million GPUs. So this is a distributed computing problem. You have a lot of these intelligent XPUs, but they need to be connected together to function as one entity. And this is why networking is very, very critical, right, in AI. And, Meta talked about at one point of time when they were doing recommendation models that 57% of the time when they were training these models, they were stuck in network. So if you can improve the network efficiency by 10, 15, 20%, you can actually reduce the amount of compute that you need by 10, 15, 20%, and you can bring down the power that is required. The second thing that's very, very important in this case is performance, because AI does require a lot of performance. And from a silicon perspective, you are limited by the size of the silicon. 800 millimeter square is the size of the reticle. But to just give you an example, what you need to do is very transformational, very revolutionary. At Broadcom, what we have been doing is working with the cloud guys, working with the AI data centers over the last 3-4 years. We have doubled the density and performance of our silicon every 2 years. I just brought something with me. What you see over here is, this is something that we call Tomahawk 6. This is the world's first 100 terabit switch. To just give you what it does for you is, this is what connects those GPUs that we talked about. If you go back 5-7 years ago, 128 ports of 100 gig, it will require a system which is this big. It will consume 25,000 watts of power. It will cost you $1 million. With this, you can get 8 times the bandwidth, 8 times the density. And when you put the system, it will be 1/7 of the form factor, consuming 1/10 the power and 1/10 the cost. So Thailand, if you're looking to build data centers, that's what you want. This actually, the clusters that you can build with this, AI clusters, you can actually, the number one thing that you're looking for is how can I fit in a large cluster within 2 tiers of a network? And you can actually fit in 128,000 GPUs with this device in 2-tier network. Nothing else can do this. Anything else needs to go to 3 tiers, which means that you are saving 67% in optics, 60%, 7% in terms of latency, and you're using 1/2 the power. So these are some of the things that this is why networking is very important, right, when you're looking at building AI data centers down the road.
Thank you, Hasan. So infrastructure is very important. So we need it right now. So that's a great look for the supply side. So now let's bring in the customer side. Good Joe. So as a leader in the high knowledge financial service industry, you are at the sharp end of these demands. So how do you balance the urgent needs for AI performance with the absolute requirement for cybersecurity, data securities, and strict compliance with regulation like Thailand PDPA? So what do you need from your partners?
So as a financial and insurance companies, right? So from our perspective, we are users, not providers. From our side, what we're looking for, basically 3 things. The first is security. Second is reliability. And third thing is scalability. Because we are issuing loans and we're working with insurance, right? So we never know when the customer would want the money, or we never know when the accident is going to happen. So we're going to need to make sure that whenever our customer needs the money, they need to be able to get it. Or whenever they want to claim insurance, we need the system available for them to make a phone call and support them with whatever that happens to them. But this requires a lot of investment because, as Hasan mentioned, right, AI applications requires a lot of power consumptions and computation power. So from our perspective, we're looking for something that's scalable and has a suitable environment for running AI applications. I think many people in this room will probably familiar with an AI applications. Recently, we have a lot of chips coming in from, for example, NVIDIA. And I think a lot of companies have a lot of difficulties, including myself, having the knowledge of how to use those chips. The first time I ran it, the fan just went crazy. It's very loud, and that's something that you cannot have inside of your company. It's just like driving a Ferrari. And I think not everyone has the knowledge of doing that. So I think it's very important that we have a very good infrastructures. I believe that's what Broadcom and Evolution already had prepared for us to use, with a lot of certificates that's certified by Uptimes. So that's what we're looking for.
Okay, thank you, Joe. So education is also important as well, right? Because the technology keep changing all the time. When we invest in the infrastructure, we need some knowledge to work with the infrastructure as well. Okay, thank you so much. So let's move back to Darren. So listen to that. So how does modern data center like Evolutions deliver the certified securities, resilience, and high-speed connectivities that a demanding customer like Ngern requires?
We are, if anyone's out there has been in the industry, it's a 20-year-old industry, really, sprung out of telco. And for the last 20 years, I guarantee you, everyone built pretty much the same data center. It would have looked slightly different from outside. It would have had different branding, different colors, but pretty much it was the same, 80, 90%. An enterprise customer could go in there, a retail customer, a wholesale customer, a cloud customer. The workloads didn't vary that much in terms of kilowatts per rack. Now, for the first time ever, you have to ask yourself before you build your data center, who's it for? So when you're talking about security as an example, whether it's physical or cyber, frankly, even if give you an example of physical security, for data centers for the last 10, 15 years, we build something like 6, 7, 8 levels of physical security between the site and the server. That was why, because most of the customers for data centers for the first 10 years were banks. Right? And the reality was banks and insurance companies were the data center business. Now, if I look at a cloud customer, they'd have the same demands. So the same physical demands, the same security demands, the same cybersecurity demands, same certifications to some degree. If I look at a GPU customer, I can pretty much guarantee you they don't care so much. They don't need to be paying for 7 levels of physical security. Give me a lock to the door. That's it. I don't need man traps. I don't need physical security. I don't want to pay for that. So for the first time ever, we've got sub-segments of the market. And data centers aren't one size fits all anymore. So are you trying to serve the cloud customers, the retail customers, the GPU customers? And there is no right or wrong. There's just different choices. And we haven't yet seen that play out, but you're going to start seeing it play out in terms of, so spec build. I'd love to spec build all my data centers. Oh man, I'd love to. But because every customer wants 3 to 9 months delivery now. Well, Core and Shell will take you pretty much that time anyway, right? That's before commission, etc. So we've got this disconnect between particularly what the GPU customers want in terms of timelines, because if they've secured that GPU, they need it to start making money tomorrow. Not wait 1 year for me to go and deliver a building for it, because then it's 1 year into its 3 years commercial expected lifespan. So do I spec build now for that GPU? Maybe it's for the Blackwell, or do I wait for the Rubin, or do I wait for the one after that, or do I wait for an AMD one, or do I wait for a Chinese one? Do I use Chinese vendors? Do I use Western vendors? For the first time ever, the operators are sitting there going, what do I do? And so that's a challenge, because it's, as I said, the biggest challenge is every customer will say, I want 6 to 9 months delivery maximum. To do that, you have to pre-bill. To do that, you have to have a very brave investor. And there's not many out there that will spec build a site now, because to my original point, who is your customer?
Okay, thank you so much. So who is customer is very important as well. So now we move into the next question. So we covered the scaling up AI and the demand of security. Like has the finals critical pillar, the sustainability. So let's start with Hasan. How does the innovations at the chips and hardware level, designing more efficient silicons, contribute to reducing the total energy consumption of AI?
Yeah, so I gave an example, right, why network is important. And, I talked about how the systems, right, how do you get the best performance and the lowest form factor? One other critical component when you're building AI data centers is optics, because optics and cables, they are the ones which are connecting everything together. And the first innovation that needs to happen is if you are building a rack in a data center, you need to be able to connect within the rack over copper, because copper is resilient, does not fail. So there is a lot of innovation that has been happening in terms of technology, which we call SerDes, that goes in the silicon to get the largest reach. The 100 gig version of the silicon I showed you, you can actually get 5-meter reach over copper within a rack. So that reduces a lot of cost, a lot of power. The second element in this space that's happening is what we call linear pluggable optics. This is where you are removing a lot of active components in the optics, and that actually also reduces 33% power and around the same cost. The third kind of, I would say, the more revolutionary technology that's coming out here is something called co-package optics. So you will take some silicon like this, and you are going to integrate the optics onto this chip itself. We just released a 100 terabit version of this chip in which you have the forwarding, but also the 100 terabits of optics which are integrated. That actually reduces the power consumption by about 70%. So that is going to be a key component moving forward. Now, another thing to keep into consideration is like there are so many data centers that you can build, which are, let's say, a few megawatts. Even in the US, there are very few data centers which are beyond 10 megawatts. I know there is talk about 1 gigawatt data centers, but there are very few of them. So what happens is if you are putting these Blackwells or Rubens Darren was talking about, at some point of time, you're going to run out of capacity in the data center. So you need technology on how do you connect multiple data centers together, but make sure that these clusters are operating as one entity, as one supercomputer. This is where this fabric across the data centers has to be lossless. You have to have a lot of security because now you're going outside your premises. And this is something that we have also launched some very recent products, something called the Jericho portfolio, that allows you to build data centers and connect across buildings. And these buildings or data centers can be 80 to 100 kilometers apart. So these are some examples of innovations, techniques that need to be used as you build AI data centers for sustainability.
Thank you so much. So now let's move to Joe. So from the enterprise perspective, how critical are ESG credentials becoming when you and Ngern select your technology and data center partner? Is it nice to have or must have?
So talking about ESG, so it's environment, social, and governance, right? In terms of environment, if I recall correctly, I just saw one of the slides from the BOI that mentions that 51% will be renewable energy by 2035. I think our strategy aligns with that also. It depends on the options that's available in the market. So AI requires a lot of computation power, as I mentioned. To use renewable energy source, we need to make sure that it also complies with the power that we're consuming. Because with the GPU that we have, the entire containment rack in data center, we consume all the energies from the whole rack, while the normal CPUs, you can probably run like 7, 8 of them. So we try to align with that, but we need to also make sure that it also supports what we are trying to do. In terms of social, we also use what we prepare for our employees and also for our customers. For customers, we would like to support them as much as we can. We want to issue the loan. And once they pay off all their debts, we don't want them to come back again. So we're trying to educate them with the financial educations. And internally, we're trying to educate our employees to build AIs. Within 3 years from now, hopefully, all of our employees will be able to have the AI skill sets on them so that they will not have to do their routine tasks, but instead they can start training AI to do their jobs and they can do something that's more productive. And finally, it's about governance. I think a good data center provides an administrative control where you get all the certificates from uptimes to certify that you have 99.99% uptime, you're secured, you have all the securities in place. So that's what we need in terms of administrative control. But also, we also need a technical control, something that we can do on our own, that we do not have to rely on the infrastructure. So these are two things that we also have in place as well. To answer the question, yes. So I think ESG is a must, and I think we need to align with that to make sure that what we do will be sustained.
Billy, can I just give a different perspective on that? So I think there's a disconnect. I think people haven't quite realized there's a disconnect. So the commitment of power comes through the operator. Okay, we don't actually make money on power. It's generally a pass-through, right? So actually we're somewhat ambivalent from a commercial point of view, but it's our responsibility to get the power to site. Now that may change in the future, but for now that's the situation, even in a direct PPA model. There's two things that it's easy for people to talk about sustainability, right? It's very easy. Everyone in this room can talk about sustainability, right? Actually to deliver it at a data center level is very hard. And it's getting harder, and it's getting harder for one reason, that's scale. Okay, if you've got a 10 megawatt data center in Rayon, so there's one that was up on the board before, and you've got land around you, you can deploy some solar, you can probably get a few megawatts of IT load supported from your solar on site. Great, there you go, you've got some sustainability metrics. Now try doing it for 100 megawatts. The names that were up there before, all want to deploy 100 megawatts minimum. So tell me how they're going to do that. Is it going to be on-site solar? I don't think so. So what is it going to be? So it's all too easy as an industry for us all to sit here and say we take sustainability seriously. The challenge is scale. And the second challenge is who's paying for it? Is the customer prepared to pay a premium for green power? Unfortunately, that's yet to be proven because when push comes to shove, they need power first, not green power. Green power becomes a nice to have. Then you've got the disconnect between the investment period and the return on a data center compared to an investment into renewable energy. They are very different. So it doesn't fit into the same fund life cycle. So it's really easy for us to sit up on these stages and talk about sustainability and how we're doing this and we're doing that. Try and do it 100 megawatts and try to make money from it. Not so easy.
Very interesting insight from the provider perspective. So we're just about like out of time. I would like to ask like each of our panelists final like 30-second takeaways. So what's your like vulnerable predictions and key piece of advice for the industry leaders in this room today? Let's start with Hasan first.
This is my first time in Thailand, so it's good to see some very specific insights. But I think this trend is very real. There will be, per McKinsey, I think 124 gigawatts of capacity that's going to be added over the next 5 years. So I agree with Darren. Like, it's really getting that power, whichever way it comes in. $5.1 trillion is the number I believe that's going to be spent in this infrastructure. And I think just looking at this country, right, you guys have the workforce, you have the talent, you have energy, which a lot of people are craving for, and you have the land. So I think you are well set to ride this trend, and things are moving very, very fast. These build outs are happening like crazy. So I think it's important for you to get on board, and there is enormous opportunity right in this region and in this country for you moving forward.
Yeah, look, this is Thailand's time. Be in no doubt, this is Thailand's time. Malaysia's done really well. This is Thailand's time. My message to the Thailand data center ecosystem, including the government, including BOI, including the power authorities, don't get in your own way. Don't screw it up. Because if you don't take it now, it will go somewhere else and it won't come back.
Yeah, I'm with you on that. I think it's time. I think everyone is talking about AI. It's like a buzzword, but it's also very important. I also agree because everyone at our organizations is using AI. So I hope everyone do the same.
So what's the perfect way to add the clear the pathway forward require deep collaborations between builder, technologists, and customer and power. Okay, we need power, right? So please join me to give a huge round of applause to our incredible panelists. Thank you for joining us today. Please enjoy the rest of the event. Thank you so much.